Please join us for the panel discussion. Now I request Eckert to host the session as the panel moderator. We also have with us John Kim, Senior Vice President, Revenue Procurement, Reliance, Balachandar Krishnan, Chief Operating Officer, Indosol Solar, Shishir Garamela, Head of Business Development, PWEL, and Rahul Bhutiani, Chief Marketing Officer, Adani Solar.
Yes, thank you, Uma. These were very interesting presentations, and Narendra, you just brought up many, many different issues and how dynamic the solar space is on the cell side, the module side, and also the different environments, how India is also very different from North America or Europe. That needs to be considered. So we'll start with the topic of quality and focus on technology and markets, focusing mainly on mainstream PV applications, so not emerging applications like agri-PV, floating PV, BIPV. There's still very small markets in India. And one thing I was recently at a big show in the US, and I met with the people at SiteView. They used to be called Drone Base, and they did an interesting study of PV power plants in the US, 1 megawatt or bigger, and the surprising result was that they found that the newer plants had more quality issues than the older plants. So, and I'm just wondering, Shishir, do you see such a situation in India as well? And what environmental conditions make India a fundamentally different market from North America? And isn't this also a challenge for Indian manufacturers as they try to serve both the Indian market with its environment and foreign markets like North America?
Right. Firstly, thanks for having me here. Great to share this, the stage with some old friends and people that I know for a long time. So thank you for having me here. That's a very loaded bunch of questions. We'll break that down, unpack it a little bit. I think your first question was on the quality challenges, was it? Or look, I think let me answer the question based on the fact that the Indian manufacturers have come of age now to sell globally, and quality is a prime concern. I think it's very critical for America to look at, or for that matter, any mature market to look at a China +1 strategy. So India, Turkey, we are seeing a lot of offshoots of new countries emerging as credible, reliable solar module manufacturers. Now, we are used to selling to hot and humid conditions. And what we are noticing over the years is poly stayed in the game for a very long time, but not a lot of change. And then monoPERC came in 2015, 16, 17, and that was in the game for another few years. But as Dr. Narendra's slide showed, every particular dimension of solar module is now changing. Glass, frame size, frameless, half cut, 1/3 cut. The size of the cell is changing. With the module wattage is changing. Now, all of that, even an incremental shift, has a massive difference on the downstream. And within solar, if you're buying for a 20, 25-year period, it's, in our opinion, better to go for something old and reliable than to go for latest and greatest and have a problem going forward. So I'm not at all surprised with what SiteView has come up with, right? Now, to answer your question on the trends that we are seeing, look, there's a lot of argument that, not argument, but a debate that the Indian manufacturers have. Should we sell glass or glass transparent backsheet to the US, right? Like most things, this is you have to weigh your pros and cons, right? I can tell you what we are seeing in our lab when it comes to testing. Glass is heavier, harder to install, harder to move, but it doesn't have the backsheet. That's why, from a reliability standpoint, it is better in heat and humid conditions, right? That said, glass in Texas or any hail-prone area has seen some very big challenges in terms of hail failures, right? Now, this is not only hail balls coming and making holes within your solar panels, but and the insurance companies putting a stop loss, but also glass cracking regardless of the hail issue. So glass has an issue on its own side. Glass backsheet on the other side has none of these hail issues. When you've got 3.2 millimeter tempered, semi-tempered glass, you have a lot more robustness from a hail perspective, but then you have the degradation. Let me share with you what one of the large developers shared with us. They've got a 300 megawatt plant, and they've taken a model, in the model they've taken a degradation of 0.5%. But for glass transparent backsheet, they take 0.6%. Now 0.6% over 300 megawatts over 30 years adds up to a lot of dollars, right? So that's why they decided to go with glass and not install glass in Texas. So sort of to summarize, there's no one-size-fits-all kind of an answer in solar. It really depends on what your weather conditions are, where you are, and how you're going to produce. India specifically has multiple climatic zones. We've got hail in India and Rajasthan. We've got a lot of heat and humidity on the coastal sides. We've got very dry heat in different parts of India. So I think we are getting to a point with so much change in technology that we need to be very specific about who we are selling to and where they're going to be using it. I think that'll probably decide what kind of module BOM is going to be applied.
Great, thank you, Shishir. So now a question to John, Narendra, Rahul, and Balachandar. How do you see specific degradation issues for PV in India, and what are manufacturers doing about it? For example, specific module packages, glass modules, specific cell types. John, do you want to start?
Yeah, sure. So thanks for having me, and nice to meet you all, distinguished guests. So in Reliance, I think we can start from the technology that we have chosen. So we have chosen a technology called heterojunction, HAT, which has, and we feel that that has the very good degradation factor. So what the warranties that we provide, the degradations that we provide, probably are one of the leading in the industry. So by having a technology that has to be known, proven that has the lowest degradation, I think that's a process, the right step. Second, Reliance takes a very extensive qualification process. It's not about selecting one material, but it's also a marriage of the materials. So we take a very calculated and very careful steps in qualifying. Most of our qualification takes probably 5 to 6 months. And that is for us, it's a very short period of time because it goes into a very rigorous testing and qualifications. And what we tend to do is that we have a reliability cycle test where the same module would start from a damp heat and we go to a TC, we'll go into an HF, and all the other tests that are necessary. And that same module will go into that rigorous testing, not once, but twice. So that we wanted to simulate and accelerate and have a stress test on the module and see how our production modules perform in the field. And I believe that while we cannot avoid all problems by selecting the right marriage of bill of materials, selecting the right technology, and then working with our distinguished suppliers to work on quality improvements, process improvements, and definitely we do have channel to feedback all our quality problems with our bill of material suppliers, and we work extensively with them to provide our feedbacks that we have gotten from the field, inform them, and see where we can improve.
Thanks, John. Rahul, over at the Adani side, how do you see this issue?
So, just continuing from what Shishir mentioned, we're decided to pursue a glass to transparent back sheet. A lot of our product is going abroad right now. We're exporting a lot of our products. So we found very high acceptance for glass to transparent back sheet. Obviously, the glass in a glass to transparent back sheet situation is 3.2 mm, so it gives a lot more comfort in terms of its performance in the field. So we've decided to go that path. In terms of the reliability, we've always wanted to check with a third party for how does our module stand up on reliability testing, and we've been using PWell for the last 6-7 years for establishing that. We've also talking to DOE. They are also coming up with some reliability testing programs. So we continue to ensure that we are part of such tests, and we see a mirror for ourselves in terms of what does the third-party testing procedure throw up to at. And in terms of our procurement strategies, we've been very conscious of how we procure or where from we procure, because like rightly said by all of the members here, what you put in is what you will get, and you will not know that today. It is like Dr. Narendra was mentioning, this is a product where you have to plan for a 25-30 year time frame and performance time frame, and therefore it's so very important that we look at what we are bringing in. And it is one of the key reasons why we are also creating the supply chain for ourselves within the system.
Yes, thank you. I think you made it clear, Narendra, how fundamentally different it is. You're talking about 30 years and more as opposed to those 3 years, like a smartphone or a notebook. So how do you see you mentioned that the standards tend to be, they developed in North America, Europe, but India has some challenging conditions. And so how do you see this issue?
Yeah, so just one thing is that the temperature accelerates everything, right? All kinds of degradation mechanisms, etc. So if you look at the standard IC 61215, it assumes that the maximum operating temperature of the module in a rack-mounted configuration would be around 75 degrees Celsius. Now, if you put a module in Rajasthan on roof, okay, and by roof I mean a flat kind of this thing, right? You can easily show that the module temperature will reach close to 100 degrees Celsius, okay, at reasonable amount of time throughout the years. So clearly the standard is exposing modules to stress levels that are lower than what it is experiencing in field, right? And we have seen this through our All India surveys in 2013, 14, 16 and 18, that modules deployed in hot climates in India degrade at a much faster rate than modules deployed in non-hot climates, right? And the difference, I was quite amused, Shishir, when you mentioned 0.5% degradation rates that people are assuming. I know that they're doing that. We have seen that in hot climates, the average degradation rates can be, as high as 1% more or more than that. But in non-hot climates like maybe Leh Ladakh, yes, you can probably get 0.5% and things like that. But in Rajasthan and Gujarat, getting that kind of degradation rate is actually quite challenging. You really need to know what you're doing in terms of all the bombs that are going into the module. I want to also add to your earlier question that the new modules having more quality issues. So interestingly, this is something that we have been observing in our All India surveys, that the older modules tend to have lower degradation rates than the newer modules. But I don't want to jump to a conclusion saying it's a quality issue, because it can be many things. In a sense, we don't know that the degradation rate is or should be constant over the life of the module. Marketing guys have put a straight line there. There's no fundamental reason why it should be a straight line. It could as well be a curve that stabilizes later on. So there could be a fundamental thing there. At the same time, the uncertainty in the measurement also reduces over time. So there are these other physics-based factors. But if you do thermography, you catch quality issues. So if a thermography guy tells you that there are quality issues, then there is probably some merit to that argument. Just based on degradation rate also, though, we have seen some similar observations.
Thank you, Narendra. Balakandar, do you want to comment on this?
Yeah. I have a slightly different perspective here because I think both the reliability, module certification, best BOM to be used is all already spoken here. As an operations guy and a technologist, I would strongly suggest that be it TOPCon or HJT manufacturing, the training of personals in the workforce is extremely important. That makes a whole difference. First thing is that. Second thing is that how to retain them for longer time. The experience comes with a price. So that's very critical to have a sustainable workforce.
Coming to vertical integration and manufacturing capacities, my first question is to John. What level of integration does Reliance plan for? What is the scale and what is the technology focus of Reliance?
So, we, how do I put this? We want to be fully integrated, but not just in solar. We want to be fully integrated in new energy, renewable. So we will start with solar, but that's the starting point. We'll expand to storage for batteries for storage, but also batteries for mobility. We are in plans to also do hydrogen and also integrate that with power electronics. So it is a full suite of activities we are pursuing, but not just fully integrated in solar, but in new energy as a whole. And to kick off that, we are starting with solar. In solar, we will be fully integrated from modules going up to cells, ingot and wafer, polysilicon. We are similar to Adani. We are also thinking about ancillary materials in all the value chains. So that is all in the plans. I think we can stay there.
So for PV production equipment, for
Yes.
module production equipment, cell and module production equipment, India is largely dependent on imports and mostly from China.
Yes.
So do you plan to produce PV production equipment also?
It has crossed our mind, but you know, to scale up at the speed that we want, we will probably at this moment depend on imports. However, but as we scale and have the built-in knowledge base in-house, the question is why not? But because we are trying to scale up in the speed that we want, we also need to build our capabilities in-house, and that will probably take more time.
Thank you. My another question is to Rahul. I would like to ask you, is India adding enough gigawatts of end-to-end solar manufacturing capacities to achieve economies of scale?
You're saying at India level?
Yes.
So yeah, like you know, it was discussed in the beginning that India is promising to become one of the largest manufacturing bases, and the PLI scheme is there. There is so many announcements made under the PLI scheme by various players for bringing in capacity into India. We are poised. If all of that comes in, I guess we should be the second largest manufacturing base in the world. But the jury is out in how much of that is going to come in. All right, with the policy wavering in terms of ALMM, no LMM, delayed ALMM, etc. You know, a lot of the domestic manufacturers even today struggle to find a market in India, and so unless we have a very firm hold on the policy, and there is commitment to encourage manufacturing the way it has been planned through the PLI, and we go down that road and, you know, stick to our plan in terms of policy for PLI, we may not have as much capacity created. But considering what we are setting up every year in terms of installation base and what we need to achieve our own goals, as the Prime Minister has set for the country, I think we have enough and more capacity, and we will have enough and more capacity. Currently, it's a little lopsided because we have more module capacity, not as much cell capacity, and none of the wafer ingot facilities yet, except what Adani has done right now of 2 gigawatts. So I think that has to catch up. But at the module level, I think we have already about 40 odd gigawatts of capacity. We install only about 15, 16 gigawatts right now. We would go up to about 30 gigawatts, all things falling in place. So we have capacity that can take care of the domestic requirements. It's just that we need to, to kind of ensure that we have a future proofing of our PV supply chain. We need to focus on some of the elements in the supply chain rather than just the end piece, which is module. So maybe cell, wafer ingot, polysilicon, that's where we need to get more capacities in India.
Okay. Thank you, Rahul. Bala, can you please tell us about the upcoming factory of Indosol Solar? What types of cells will you be producing, and what is your technology focus, and how are your technology partners helping you?
Yeah. So we have chosen TOPCon as our technology choice, mainly for the purpose of being cost effective compared to HJT at this point of time. But of course, future can change. So for the first phase, we are going with 10 gigawatt of TOPCon technology, and that will be for ingot to module. And a separate 10 gigawatt polysilicon plant is being planned. And this should be up and operational in 2025. Yeah. And your second question was?
What types of cells are you producing, and what is your technology focus, and who are your technology partners?
Yeah. So we are working with partners from Germany, from RCT Technologies, and then we are also working with US partners, which I cannot tell it open forum. And then we also have partners in China.
So now we'll turn to the very important topic of the talent pool. India needs to have this resilient PV supply chain. And maybe a question, whoever wants to address it in the panel, what is your view on the volume of skilled workers to produce high efficiency cell technology? HJT, TOPCon, XBC, do you create training programs or exchanges between industry and colleges, universities, research institutes? Another thing you might want to comment on is yesterday at the CEO conclave, there was sort of a discussion about this technology gap between India and especially China. But then the point was made, as India scales up, that'll automatically address this gap, because with scale, you really gather a lot of know-how. So it's really the scaling that's central and not the gap. So whoever wants to comment on these questions, please.
Yeah, so, I think it's one of the most important, maybe the real burning issue today about talent. In some form or way, this industry is completely new for the country. All of you know that the capacities are very concentrated. All of the capacity, if I may be a little liberal on that, all of the capacity is in China. What we have outside of China is hardly anything. So any part of the supply chain, if you look at the capacities, ranging between 80 to 95% is in China. So obviously the talent is there. What you have outside of China majorly is maybe cell and module to some extent. We really don't have anything. Wafer, 95% of the world capacity is in China. And I guess the balance would be somewhere in Southeast Asia. So we really don't have talent here that has been exposed to this, these manufacturing processes. And so it will remain a problem that needs to be solved. And there are creative ways being thought of by all manufacturers to address this. You know, how do you get people to get trained when you don't have access to the technology? How do you get, you know, people to come in from or from organizations that have experience? So all of this requires a lot of creative approach. Unlike in most industries where you could, you know, just send them to a training institute or collaborate with let's say the academicians and create some training programs in colleges, in universities. I think here we will have to do a lot more creative thinking on how do we get talent trained and ready for the big move that India is going to see in terms of the PV supply chain.
Narendra, you mentioned earlier before the panel that there used to be this salary gap between, you know, graduates from IIT Bombay. Many were going to the semiconductor industry because they could get much better salaries, but that gap has come down. So maybe you can comment on how, you know, institutes like IIT can really help bring talent into this industry.
Yeah, so at IIT we have this NCPRE where E stands for education, and MNRE had asked us to actually train a large numbers of students, professionals, etc. And in last, I would say in 12 years or so, we have trained more than 1,000 students, okay? And by train, I don't mean 1 week of training or anything. It's like they have undergone more than 2 semester-long courses. So for 1 year, they have at least worked intensively in the area of PV, right? But where are all these 1,000 people? They mostly got employed by the semiconductor industry because the skills that the semiconductor industry asked for and the solar industry asked for, they're more or less similar, okay? And they are offering salaries that are, double or something like that, right? So unless somebody is really devoted to solar, there are few individuals like that, but then most of those kids just went to semiconductor industry. But now what we see is that with all these manufacturing, facilities being set up, solar companies are coming for campus placements. Reliance, Adani, they came for campus placements at IIT Bombay. So the picture is changing, and kids are actually going to these companies, and that's a good start. I would say solar industry also needs to provide maybe a little bit competitive salaries. And I think if the market, if the whole thing is about exports, then maybe it will be possible for. But for domestic, if it is just meeting domestic demands, then I don't know. Semiconductor industry actually has a much higher, margins and so on. That's why they can actually afford to do that. I hope solar reaches at that point. The one more point I would like to mention was that retaining the talent, right? That's actually $1 million question, because in solar industry, I see there's a lot of movement, not just at a lower level, but even at a higher level, right? If you just look at REI, same people, but different affiliations probably, right, within 2 years. So we want to set up something fundamentally from scratch and see it grow and all that. So you have to be at one place for a reasonably long amount of time. How to address that is actually, I don't know, it's a challenging problem.
Yeah, John, how do you, you're saying Reliance is really trying to do this energy transformation across new energy. So it must be a huge challenge. How you can find the people for green hydrogen, for this advanced solar manufacturing, all through from, the materials to the module?
Yeah, for Reliance, so I used to work for a company called REC Solar, which Reliance acquired. So for our solar talents, there is a cross-training that is happening so that our engineers, our operations are trained by REC technology, REC production, but also the business systems that are proven in the industry. So that's one. Two, yes, you're right that some of the talents are very difficult to find inside India. This is why I think we are mobilizing global talents. And we mobilize global talents to come to India to support this, the new energy initiative. And also, by then, we would like to develop the talents here. The good thing about right now is that there is a huge talent pool who is trying to come into new energy, who is very interested. So I think that's the good part. So once we have this global talents mobilized, come to India, support this ramping up and developing the talents, I think when we reach the scales of 70, 80, 100 gigawatts in India, I think it will be self-sufficient.
Yeah. My question is...
I want to add something here. So training basically adds a very good initial support for all the workers who are getting inside the company. So how it happens is most manufacturers either they start a pilot line, something like a very small line, train their workforce in that, and before going to the a bigger line, or they send their employees abroad, be it China or Germany or US. Let's say they send 50 or 60 workforce there. Yeah, 50 or 60 workforce there, get them trained very well, and then those will be like the core team who will train the other set of people. So this is how it works for the training.
Just to add to the point, you made a very interesting point. We did that with our ingot wafer plant. We've set up just one, we brought in just one puller, one wire saw machine for slicing, and let the team work on that for like 6 months, just trying out the pullers, and so I think now they're ready. When we have the 150 volt pullers all put up, there is a core team that understands this whole process, and so that's an interesting point you brought out.
Yeah.
You want to be polysilicon?
So, Rahul, I would like to ask you, what are the sources of polysilicon for Indian manufacturers currently? And do you think the process of polysilicon production is as complex as it is thought to be?
To answer your last question first,
Okay.
I am not a technologist, so for me to answer would be very wrong. Maybe somebody who
Any of the
understands.
panelists who would like to discuss this?
Okay. I think in terms of technology of the whole value chain, polysilicon is the most difficult part.
Yes.
This is known to all, and many times there were abrupt failures. So this is also the reason why not many players are not interested to come into this, apart from huge investment point of view.
Huge investment is another major factor.
Yeah.
In terms of sources of polysilicon, Indian manufacturers have only 2 options. It's either China or it's non-China. Non-China is hardly 40 to 50 gigawatts outside of China. That's available. 40 to 50 gigawatts worth of polysilicon capacity available outside of China. Rest, all of it is in China. And this 40 to 50 gigawatts capacity is really difficult to identify and book because apparently it's always booked for the next couple of years. And so it's a little suspicious about all this booking. I mean, who's booking this when it's supposedly double or more than double the price that it is in China? But irrespective of that, it's very difficult to source polysilicon outside of China. And even if you are able to get lucky and get some source, it is going to be more than double the price than it is in China.
It's not just the price alone, but in fact, if you want to go for bigger companies in Germany or US, they are even asking you to invest in their new plant.
Yeah, exactly.
Thank you,
Invest
Rahul.
on the new plant.
Thank you, Balachandra. Eka, do you have any further questions on polysilicon?
Yeah, let's maybe the last question here for the panel. I think what's also very important that we as a sector, be sustainable. So maybe I know that Reliance, I think it has a goal by 2035 to be carbon neutral. That's very ambitious. But generally, what your organizations are doing to be sustainable. I know some areas like Europe, regions, was looking at carbon, looking at the emissions produced by making solar products and other products. So it's becoming more and more a topic simply to do business in overseas markets. So what are you doing on that front?
I think the bigger question is that for every aspect that you expect on this front, there is a cost associated. The solar industry currently is in such a state that we are really not even willing to pay the real cost of the product. I don't know how we are expecting the industry to start investing in making it sustainable and look at end of life and figure out what will you do at the end of life. I mean, it's no secret here that the developers in India don't even want to pay the actual price of the product. And therefore, we don't have domestic manufacturing able to sell to Indian companies. So rightly pointed out, if exports can give you some margins, you can be more profitable. You can start using that money not only to attract talent, but also do all of this stuff which is very necessary. I mean, you're saying you're renewable, but if your production process is not sustainable, how renewable are you? How green are you? So it's a very important point, but at the same time, not much we can do right now as an industry because we're still trying to find our feet in terms of whether we'll get even paid for what we produce, rightly what we spend in producing what we are supposed to produce.
Balakanda?
Yeah. Few points I want to add is actually I see some small changes are happening. Some sustainable practices like usage of LED lamps, right design for your HVAC, heating ventilation for your plant, then recycling the water, then zero liquid discharge. All these are coming up. Yeah, so I think this is just a baby steps which are.
It's the beginning. Yeah, we're doing what we can, but
exactly.
If you seek an answer as to what happens to the module after its 30-year life, I don't think any one of us is really addressing that right now. And because maybe the immediate challenges are so significant that you really don't know whether that's what is on your priority right now, or
exactly.
or survival and actually growing is what should be your priority right now.
But I guess it does become an issue at some point with some of these plants being pretty old. If you start having a lot of module junk which doesn't look good, there's this acceptance problem for us.
It's definitely a problem that we are going to stare with so much of deployment happening the world over. We're doing, 300, 400 gigawatts a year of installations. All of these will become end of life in maybe 15 years. Technology changes so fast. Most modules don't even see the 25, 30 year that we seek to create as reliability. Most modules get replaced even maybe in 10 to 15 years because technology progresses so fast that it's better to replace a module than to wait for end of life, right? So all of that material, how do we recycle, reuse, repurpose those materials is something that the industry will have to work on very aggressively. I think there are some initiatives being done there too, but I guess momentum needs to come in there, and maybe a year, 2 years, 3 years from now, we shall see baby steps there too.
John, what's your ambitious 2035 goal at Reliance? So how are you tackling this big challenge?
Yes. Well, I mean, first of all, we will install the panels that we produce. So that's one. Yeah. So self-consumption is a place to start. But on a baby step level, I mean, what we are doing from a material perspective is ask for what is your carbon emission. By taking a baby steps to understand the materials that we source and what is their contribution to carbon, it's a baby step that we can take. And also the suppliers are also coming out with, upfront saying, we are one of the more carbon free or carbon less
intensive. Yeah.
Less intensive. Even I guess from all the way from logistics, materials, production. I could also say that heterojunction doesn't use. It's a very low temp technology. We don't use. Nothing in our production goes over 200 degrees Celsius. I think that's a place to start.
Thank you. I think We have some room now for questions from the audience. If anyone has questions for this very distinguished panel, now is the time. We have microphones. Please go ahead.
Good evening to all. Able to hear me? Hello. Yes, myself Prabhu from Chennai. I'm a research scholar from SRM University. Basically, it's a generic question, open to all. Is there any space for the startups in the solar field? Is there any gray area that need to be addressed? Or like, are you facing any challenges in the module manufacturing that can be addressed by the startups, particularly? Thank you.
Yeah, who wants to tackle that? Sishir?
I've seen a lot of startups emerging in the post-deployment side. Yes. So if your question is around manufacturing, I've not seen too many. But if you look at after deploying the project, drone mapping, diagnostics, all of that, there is a huge area for startups to come in. There's also a big space for SaaS, software as a service. That's another area that I've seen a lot of startups come in. I've also seen a lot of startups in the downstream part of the business where, the companies startups that help design solar projects, either rooftop or even larger utility scale projects. I've seen CRM-based, check out a company called Aurora Solar, A-U-R-O-R-A, they're a very big company. Then Zeit, you said ZiteView is ex-drone base. Yeah. Then PV Case, solar design software. So there's a lot of work that startups can do. But during manufacturing, I haven't seen too much because that's a very technology, R&D, capital-intensive process, which is not what VCs like to back.
And would you recommend any startups that initially starts with the module manufacturing at the small scale, like just for us?
I don't know of. I know of a company in Chennai called RenCube that has. They do some sort of a technology where you can concentrate the power. I know a company in Switzerland that does something similar. So they do agro photovoltaics, but again, concentrating solar power on top of. But a lot of these things have to take off. So if you're at it for many years and it doesn't scale, I think that's a sign that you need to probably change. So I don't know too much around the manufacturing side, but we can definitely speak one-on-one about a lot of things that startups can do after the modules are installed.
I'm asking for the module manufacturing itself, like just to start.
That's probably a better question for them.
I think automation, robotics, AI. If you have any such capabilities, then there's huge opportunities.
Thank you.
So actually from IIT Bombay, there was one spin-off startup that came out from NCPRE, our own students. What they did was, the electroluminescence cameras, right? Earlier, they used to be very expensive. So they figured out a way to convert a DSLR camera into electroluminescence camera. So when they actually did that a few years ago, the reduction in price versus, when compared to the market price was 10 times. So they did not just provide the camera to our lab or maybe research organization. They also sold it to people in US and Europe where they're happy to get just as good of an EL camera as compared to the expensive kind. So it is possible to also do it in equipment side, but maybe I would say test instruments and not so much like manufacturing equipment, but because that's at a different scale and so on. Also, this AI-based, people are doing this AI-based crack detection and so on in EL images, right? So you can do that too. You can train a neural network. You need a lot of data though, but then the accuracy levels have to be better than the yield of a module manufacturing line, right? The yields in good lines are more than 98, 99%. The accuracy levels that I have seen are of the similar order. So you can't have a software tell a good module as a bad one, right? That's not worth it. So if you can design a narrow AI that is smart enough to get 99.99 kind of accuracies, then maybe there is a case there.
Okay, I think we'll wrap it up with that. I just want to thank the panel for this very interesting discussion. I think oh, there's another question. Oh, I'm sorry. Please go ahead. We still have some time.
Good evening to the panel. My name is Vibhuti and I work with CW, and my study involves studying the supply chain dynamics for solar, wind and batteries. And my question is to Dr. Balachandar Krishnan about, we heard that you are trying to come up with a 10 gigawatt facility for polysilicon to wafer manufacturing. And my question is specifically from the perspective of how are we aiming to procure these facilities within the country in the time to come, because once we get hold of the technology, the second step, I think, which the manufacturers would be aiming for is to establish the wafer manufacturing facilities and procuring their components from within the country. So there are specialized things like silver paste, which goes into making of cells, and diamond wires, which are used in cutting the wafers. So in what way can India look forward to making these materials on its own, and what kind of time frame would it take to establish these facilities within our country? Thank you.
Yeah, thanks for asking this question, because at this point of time, there are a lot of module raw material bomb makers inside the country, but with respect to polysilicon or ingot or wafer or even cell, it's extremely rare. As you rightly pointed out, we don't have any paste or screen makers, or even we import all the specialty gases that is used in the cell line. Then the crucibles, hot zones, everything has to come either from Germany or mostly from China, I would say. For the moment, I think the big companies are looking at setting up their own manufacturing ecosystem, like what Mr. Rahul has already shown for Adani Solar. They are focusing mainly on the module bomb for the moment to secure the supply chain. But on a long-term perspective, yes, India has to come up, especially the government has to support for this, to create the raw material ecosystem as well as equipment manufacturing. And this is a future scenario. It all depends on the government support. Yeah.
Thank you for that question and answer. So it's been a very exciting discussion. I guess we have to create a whole ecosystem, including the materials, components, gases. It's a big challenge, but I think India is well underway with these PLI scheme and the government support, and big players, small players, hopefully more startups involved. So on behalf of PV Magazine, it's been great moderating this session, and we'll also write about it on our global trade media platform, our India website, so you'll be able to read also about this, this very interesting session today. So thank you everyone for attending, and especially thank you to the panel.
Kindly stay seated, and thank you for joining us. Thank you to the panelist and the moderator for such an informative session. Sir, I would like to request you to kindly be there, and would like to request to the moderators, Eckhart Chorus and Ms. Uma Gupta, to present the memento and the gift to all the panelists to honor them. Thank you. to honor and acknowledge our moderators as well. Can we have applauses for our moderators? Come on, everybody. Thank you.